Hello students, this is Nilanjana Sanyal from onlinemathtutor.me and ePorashna. Today we will be learning about the trigonometric ratios of the sum of two angles. We know about the trigonometric ratios of single angle, sine of angle theta, cosine of angle theta, tangent of angle theta and so on. But theta is a single angle and in place of theta we can use any other English alphabet as well, like sine of angle A, cosine of angle A, or sine of angle B, cosine of angle B, etc. But in this session, we will be learning about the trigonometric ratios of the sum of two angles. So there will be two angles and we will be knowing about the trigonometric ratios of the two angles taken together. So let's start. OC is a ray. Let a revolving ray start from OC and trace out the angle COD, which is equal to angle A. Now, let us assume that there is another ray lying on top of this ray OC and which is starting its revolution in the anti-clockwise direction. So this is the present position of the revolving ray and this angle COD is equal to angle E. Now this revolving ray continues to revolve in the anti-clockwise direction and traces out another angle DOE, which is equal to angle B. DOE, this angle is equal to angle B. This is the final position of the revolving ray. Okay? Let E be a point on the final position of the revolving ray. Now these two angles taken together will be sum of angle A plus B. And we have to find the trigonometric ratios of these two angles taken together. So for that, we draw a perpendicular PM from this point P on OC. So let PM be perpendicular to OC. Now as soon as we have this perpendicular dropped, we have this triangle POM, which is a rectangle triangle, right angled at this point M. That is angle PMO is equal to 90 degree. So we can say sine of angle A plus B will be equal to PM by OP. But we would like to have the expression of sine A plus B in terms of individual angles A and B. So for that we draw some more perpendiculars. Let PN be perpendicular to OD, this one. Again, let NR be perpendicular to PM. NR is perpendicular to this line PM. And let NQ be perpendicular to OC. NQ is perpendicular to this line OC. Why have I drawn so many perpendiculars? You will be coming to know very soon. Now RN is parallel to OC. RN is parallel to OC. Why? NR is perpendicular to this line PM and of course CO or CM is perpendicular to this line PM because PM is perpendicular to OC. Therefore CM is also perpendicular to PM. And since these two lines NR and CM are perpendicular to the same line PM, therefore we can say NR is parallel to CM or RN is parallel to MC or OC. So RN is parallel to OC. Therefore angle RNO, that is this angle, RNO, that is this angle, the small angle, is equal to angle A because these two are alternate interior angles. You see, this is the transversal ON and RN is parallel to OC. ON is the transversal, so angle RNO and this angle NOC, which is equal to angle A, they are alternate interior angles, so they will be equal to each other. Therefore, angle RNO is equal to angle A. Also, angle RNP, this angle is equal to 90 degree minus angle A, because angle PNO is a 90 degree. Angle PNO is a 90 degree because PN is perpendicular to OD. Therefore, angle PNO is equal to a 90 degree. And we have found the measurement of angle RNO equal to angle A. Therefore, this angle PNR or angle RNP is equal to 90 degree minus A. So what will be the measurement of this angle RPN? In right angle triangle RNP, that is this one RNP, angle RNP, that is this angle, plus angle RPN, that is this angle RPN, this one, is equal to 90 degree, because triangle RNP is a right angle triangle and angle PRN is a 90 degree. Therefore, the sum of the other two angles will be equal to 90 degree, and we have found these are the two other angles. And we have found the measurement of angle RNP, that is this one, to be equal to 90 degree minus A. Therefore, what will be the measurement of angle RPN? Obviously, it will be 90 degree minus this angle RNP. So, it is 90 degree minus this whole thing, 90 degree minus A, which gives us the measurement of angle RPN to be equal to angle A. Okay, so this angle is equal to angle A. Now we come to the sine of angle A plus B. As I have said before, that it will be obviously equal to PM by OP, that is angle COP is angle A plus angle B, or sine of A plus B equal to sine of angle COP, which is equal to PM by OP. Now, we want to express this sine of angle A plus B in terms of trigonometric ratios of individual angles. That's why we have drawn so many perpendiculars. So, that is why we are writing PM as PR plus I. Okay? And then we separate the two terms, so that it becomes PR by OP plus RM by OP. PR by OP and RM by OP. Now, we see that RM, this is not a side of any triangle. So, we take NQ, because RNQM is a rectangle. Therefore, RM is equal to NQ, and NQ is the side of this right triangle, NOQ. But RM is not a side of any single triangle. Therefore, instead of RM, we take NQ. Because we have to get the trigonometric ratio, so we have to take the sides of any triangle, any right angle triangle. Therefore, instead of RM, we are taking NQ. So, we write, instead of RM by OP, we are writing NQ by OP. Next is PR by OP. PR and OP. Again, we are seeing that these two sides, they are not the sides of in a single triangle. They are sides of a triangle, but not of the same triangle. So, but we have to get the sides of the same triangle as the numerator and the denominator, so that we can express them as a trigonometric ratio. So, PR, if we take this PR, this is not a hypotenuse. So, we have to get the hypotenuse. For this triangle PRN, PN is the hypotenuse. So for PR as the numerator, if we take PN to be the denominator, we have taken that. PR has been written in the numerator and PN has been written in the denominator. So since we are taking PN in the denominator, we have to take PN in the numerator as well. And we have this OP. So this has to be written as well. So we are writing PR by OP, or this PR by OP, as PR by PN multiplied by PN by OP. Again, this NQ by OP. NQ and OP, these two are not the two sides of a single triangle. So again, we take NQ and ON. These two are the sides of this single triangle NOQ. So we take ON as the denominator for NQ, and since we are taking ON in the denominator, we have to have ON in the numerator as well. And we are having this OP in the denominator. So it becomes NQ by ON multiplied by ON by OP. So sine of angle A plus B equal to, what is PR by PN? Coming to this right triangle PRN, PR and PN, what was this angle RPN equal to? Angle RPN is equal to angle E. This is equal to angle E. And PR by PN, these two sides, of course PN is the hypotenuse, and since PR is touching the angle A, therefore this becomes the base for angle A. So PR by PN is the cosine of angle A, and PN by OP. PN and OP. For triangle PON, if we take this angle B, PN becomes the perpendicular and OP becomes the hypotenuse. Therefore, PN by OP is sine of angle B, plus NQ by ON. NQ, ON. Coming to triangle NOQ. NQ, if we take this angle A, with respect to angle A, NQ is the perpendicular and ON is of course the hypotenuse. So NQ by ON is sine of angle A. Okay? And ON by OP. ON by OP. Now for triangle PON, this is angle B and ON is touching this angle B. Therefore, ON by OP will be the cosine of angle B. So I have written this. Now I have just rearranged the two terms because it is customary to write sine A cos B first. So I have written sine A cos B plus cos A sine B. Sine of A plus B is equal to sine of angle A multiplied by cosine of angle B plus cosine of angle A multiplied by sine of angle B. This is the formula or the expression for sine of A plus B. Okay, now coming to the cosine of angle A plus B. Cosine of angle A plus B, coming to this triangle POM, obviously it will be OM by OP. Cosine of angle COP, because angle A plus B is equal to angle COP. So cosine of angle A plus B equal to cosine of angle COP, which is equal to OM by OP. And since again we want to express this cosine of angle A plus B in terms of individual angles, trigonometric ratios of individual angles, we divide this OM in two parts. Now what is OM? OM can be written as OQ minus MQ or QM. So we write, in place of OM, we write OQ minus QM. OQ minus QM. Why OQ minus QM? Because OQ is a side of this triangle NOQ and QM is equal to RN, so we can take this triangle. So we have made this division. OM has been written as OQ minus QM. And next we are dividing or separating the two terms. So it becomes OQ by OP minus QM by O. And as I have said just now, in place of MQ, we are taking NR or RN, anything. Okay. So OQ by OP, we keep it as it is, and this becomes NR by OP. Now OQ by OP. These two are not the two sides of a single triangle. Therefore, we bring this ON. We make it as OQ by ON multiplied by ON by OP. See? OQ by ON multiplied by ON by OP. Again coming to NR by OP. NR and OP, sides of different triangles. So we take another hypotenuse, this PN. This is the hypotenuse for triangle, right triangle PRN. So in place of NR by VOP, we write NR by PN and PN by OP. So NR by PN multiplied by PN by OP. So what do we have as cosine of A plus B? It is OQ by ON. OQ by ON. Taking this triangle, right triangle NOQ, this is this angle A. So OQ, since this OQ is touching this angle A, so this becomes the base. So OQ by ON is cosine of angle A. And ON by OP. Cosine of angle A we have written ON by OP. Coming to triangle PON. ON is touching this angle B. So ON becomes the base of triangle PON with respect to this angle B. So ON by OP becomes cosine of angle B. So it is cosine of angle A multiplied by cosine of angle B. Then comes the minus sign. Now it is NR by PN. NR by PN. Taking this right triangle PRN, this angle RPN is equal to angle A. So NR or RN by PN is perpendicular by hypotenuse. So it is sine of angle A. And PN by OP. PN by OP. Taking this triangle PON, PN, and this is the angle B. So PN becomes the perpendicular and OP is the hypotenuse. So PN by OP is sine of angle B. Therefore, we have cos A plus B is equal to cos A cos B minus sine A sine B. Or cosine of angle A plus B equal to cosine of angle A multiplied by cosine of angle B minus sine of angle A multiplied by sine of angle B. So these are the two trigonometric ratios of the sum of two angles. Now let me just write the tangent of the sum of two angles. It is very easy. Means all the other trigonometric ratios, the other four can be deduced from these two. So we usually do not write, but even then I am giving you the tangent of A plus B. Okay. So let me write over here tangent of A plus B. Obviously this will be equal to sine of A plus B by cosine of A plus B. So this implies, instead of writing tan A plus B over and over again, tan is tangent of A plus B. So I am writing left hand side is equal to, we are just writing the expressions for these two trigonometric ratios. it is sin A cos B plus cos A sin B divided by cos A cos B minus sin A sin B. Now if we divide the numerator and the denominator by cos A cos B, what do we get? Implying left hand side equal to sin A cos B divided by cos A cos B plus cos A sin B divided by cos A cos B. Okay, so this becomes our numerator. I do not have sufficient space where to write. Okay, please excuse me because I do not have proper space. So this becomes our numerator, and then coming to the denominator part. Cos A cos B divided by cos A cos B minus sin A sin B divided by cos A cos B. This becomes our denominator. So we write tangent of A plus B is equal to, coming to the numerator, sin A cos B by cos A cos B. Now these two cos B part cancels, and we have sin A by cos A, which is equal to tan A, or tangent of angle A. So we have tangent of angle A plus B equal to tangent of angle A plus, now for this term we see we are having cosine A on both the numerator and the denominator, so these two will get cancelled, and we have sine of angle B and cosine of angle B. So sin B by cos B is tan B. So tan A plus tan B divided by, coming to the denominator, because this is the division symbol, cos A cos B divided by cos A cos B is a simple 1. 1 minus sin A by cos A is tan A sin B by cos B is tan B. So we have tan A plus B equal to tan A plus tan B divided by 1 minus tan A tan B. In likewise manner, you can get the other three ratios, trigonometric ratios as well. I am not deducing them, but I am leaving it as an exercise for you students. So students, this brings us to the end of this session. Thank you for hearing.